So what have we got? We've got this is y equals f of x. Looks like this. Looks a bit like a cubic, but I'm not sure I actually need to know that it's a cubic. Maybe it is a cubic, maybe it's not. Okay. What's its key features? Well, it's got a y-intercept over here. It's got a repeated root, it looks like, over here. And then I'd like to imagine what y equals f of minus x might look like. So, people who are new to transformations, this means for a given value of x, first work out minus x, and then work out f of that function, f of that value. So, xy, I want f of minus x. So, when I put in somewhere number over here, if x is over here, then I'll do minus that, and I get a number that's over here somewhere, and I work out f of that, and I get 0. I'll get something like this. When x is 0, I'll put in 0, or work out minus 0, well that's 0. F of 0 is still what it was. Oh, actually I think this is going to be a reflection, and some people I think know the relationship between the equations like this and what the translations look like, or what the translations or transformations look like in terms of geometry. So this looks like a reflection in the y-axis. Okay, which one's that? That is this one, isn't it? That's B. Okay. What next? Let's look at f of x minus 1 next. So this says take your number x, subtract 1 from it, and then work out what f of that is. This means, so this is a translation. This is how you do a translation 1 unit in the positive x direction. Where it's a little counterintuitive that it's got a negative sign in, but it moves things in the positive x direction. That's just something that you need to get used to, I suppose. Okay, so f of x minus 1. So when I put 1 in, it gives me the value of 0, so that's over here. So I guess it looks something like this. And that doesn't really look like any of these pictures. At best, I guess it could be C. If this is minus 1, then maybe this could work out to be C. Okay, C, maybe. And minus f of x is the easiest, because that just says work out f of x and then do minus it. Minus f of x, like this, which is A. Okay, so now I'm happy. This is BCA. Okay, next part of the question. This is just curve sketching part of the question. We've done transformations, time to look at some curve sketching. Sketch on the same axis graphs of both of the following functions. Y equals 2 to the minus x squared and y equals 2 to the power, let's write that a little bit bigger for you, 2 to the power of 2x minus x squared. Carefully label any stationary points. An idea that people in chat seem to be coming back to is to maybe relate these things together. The previous part of the question was about transformations. Maybe one of these is a simple-ish transformation of the other one. That'd be good, because then we could save time by just drawing one of them and doing some transformations on it to get the picture for the other one. I'm going to try and draw the left-hand one, 2 to the minus x squared. First, here's a picture of x squared. X squared is 0 when x is 0, and it gets bigger for positive and negative x. You knew that, but here's a picture of that. Right, now I'm going to try and do harder task. It says same axes. I think I'm going to just draw some small axes over here first. I might do this in a moment. I'm going to have a go. 2 to the minus x squared. Okay, so when x is 0, this is 2 to the minus 0. Minus 0 is 0. 2 to the 0 is 1. Go through 1. And other things I can think of. When x is really big, this thing's going to be 2 to the minus huge number. When you do 2 to the minus huge number, that's like 1 over 2 to the x squared. So that's that's equal. So when x is really big, this is really tiny. So I'm going to draw this getting really small when x is really positive, and actually when x is really negative as well. I suppose this has got this is symmetric. that when you put x in, you get the same thing as when you put minus x in, because you're going to square x. That's the very first thing you do. In between, I think it sort of just goes up. I think its biggest value. So the biggest value of this function is going to be biggest value, which is not great language for stationary point, but the biggest value is going to be when minus x squared is the biggest. Minus x squared is biggest, well, that's less than or equal to 0, so that's biggest when x is 0. Okay, so its stationary point, its kind of maximum value, is going to be at x equals 0, y equals 1, stationary point. And to be honest, you could just go and think about the graph on the right separately. You know, think about 2x minus x squared first, and then think about 2 to the power of that function. But what everybody seems to be telling me in chat is that they started looking for a way to relate these things together. Or they started playing with this quadratic here to say, can I simplify this quadratic somehow, in the hope that that makes this similar to the other curve. Here's what happens if you start playing around with the quadratic. So 2x minus x squared. Isabella and George both said we should complete the square. We should take, so when you complete the square, you do something like this. I think that gives me the x squared term right and the x squared term right, and then I want to subtract 1. I think, or add 1, add 1, add 1, because I get a minus 1 out of this, and then I want to add 1 back again. Sorry, you can tell I'm thinking hard when I have to lean back to get further away from it. Minus 1 plus 1, yeah, okay, that works. I've completed the square. And so, what we've really got here, or what we've got here, is this. That's what we'd like to draw a picture of. Okay. I saw someone in chat simplify this a bit more by using some laws of indices now to say, I know what this is. This is 2 to the 1 times 2 to the minus x minus 1 squared. Which is a good step to make, because now this bit looks more like the thing we just drew, but with x minus 1 instead of x, and then there's a multiply by 2 out the front. So what does that mean? So that means that we can get from here, the first one we drew, to the second one by doing some transformations. First there's a x minus 1 in there, so the transformation, transform, shift 1 unit, use words, translate 1 unit positive x direction, and then the 2 out the front means stretch parallel to the y axis, stretch it up, scale factor 2. Okay, that's what those transformations mean. I've remembered some of my theory about how the equations relate to what the transformations geometrically are. Okay, this is pretty clever. This means that we just need to draw this picture again, but shifted over by 1 unit and doubled, twice as tall. Okay, it asked me to draw these on the same axes. I've disobeyed that, so I'm going to lose some marks if I hand it in like this, but maybe I'll draw another picture with both of them on the same axes. And I've got to label my stationary point. I suppose we shifted the stationary point across 1 unit, and we doubled the values, so it's going to be at 1, 2. This picture might be a bit of an exaggeration, actually. Anything else I should comment on? When I've drawn this kind of point kind of weirdly, but I was sort of thinking about the y-intercept as well, and maybe we could label this point. It doesn't tell us to, but I think we might think about it. When x is 0, this is 2 to the 0 again, so this goes through 1. So if I drew these on the same axes, really maybe I'd draw these on separate axes on some of the blank paper at the back of the back of the test paper or something like that. Then I can draw them on both. I draw that with, this is the wide one, 2 to the minus x squared. And then the taller one is twice the value but shifted, so it's going to be something like this. It's going to go through the same point, coincidence I think. I go up, and come down like that. But look much nicer. Ooh, dearie me. Right, okay. This is written with the notation like it's a function of c. So you've seen this notation before for like f of x that we were just talking about with the brackets. Because it's sort of a function of c. You give me a number c, I go and calculate this integral, and then I return and I come back and say, here's your answer for what I of c is. The question wants to know, what's the value of c for which I of c is the largest? Briefly explain your reasoning. You're not asked to actually do some differentiation or work out the maximum value. Here's what people are saying. So first, think about y equals 2 to the minus x minus c squared. That is 2 to the minus x squared, which we had before, but translated c to the right. I mean, in the positive x direction, but I'm saving writing. So it's this curve, which we said was symmetric and decayed away, or was very small, far away from x equals 0, for a very large x, very negative x, sort of small numbers. And what we've got is we're going to shift this by an amount c. So it's going to be something like this. I guess this is like the idea we have for the previous part of the question, where we translated that function along by 1 unit. Here, if we translate it along by c, then the maximum is going to be at c, 1. So we're not going up and down, we're just going sideways. This is y equals 2 to the minus x minus c squared. We're going to integrate this between 0 and 1. Okay, so here's 0, maybe 1 is somewhere over here, maybe. And we're going to work out this area by doing this integral. Okay, so we want this interval to be, or we want this area to be nice and large. What should we not do? So we should not make c really big. If we make c really big, then the peak will be over here somewhere, over at c, 1, and we'll be integrating between 0 and 1, and we'll just get the tail of the function, which is not what we want at all. And we should also not make c very negative, because if we make c very negative, then we'll just be integrating between 0 and 1, and we'll get this little tail of the function, which is going to be very, very small. We want as much of the large bit of the function as we can get. We want to shift the function along so that we're not integrating this tiny tail bit, we're integrating the bit where the function's tallest. Okay, so we want c to be probably somewhere between 0 and 1. Oh, not going up again, going down. Something people in chat are saying is we probably want c to be 1/2. Because if we make c 1/2, then we get this kind of nice symmetric picture with some area on the left, some area on the right. We've got the biggest bit right in the middle. We've lined up the curve so that we've got the biggest middle bit of the function. And we want that maximum value. And that's actually the right answer. We want to take c to be 1/2. So if we want c to be 1/2 to get the kind of bit of this function where the values are the biggest. I'm not quite sure how convincing I find this. I think it's really important that the function is symmetric, so that there's no kind of, if it was lopsided, then you might want more of the bigger side and less of the skinny side. But here, because it's nice and symmetric, you probably want it sort of perfectly balanced in the middle. People in chat are telling me to complete the square, which I can't wait to do. Let's have a go at that. So I'll need to write this denominator of the fraction, minus sign, minus 5, is equal to, what is that? That's minus x minus 2 squared minus, hang on, so minus x squared, I've got my 4x, I've got my minus 4x, and I've got my 4 minus 1. Okay, so I think this is minus 1 plus x minus 2 squared. Okay, let's have a go. So what does this mean, this graph y equals this look like? This is some quadratic. It's got some minimum value at x equals 2. It's quadratic. And away from that, okay, I suppose maximum if I allow for this minus sign. So just thinking about this quadratic, it's got a minimum value at x equals minus 2. I know there's a minus sign. 1 plus x minus 2 squared. Okay, and then I want to do 1 over that. So I want to do y is 1 over this is going to be minus 1 over 1 plus x minus 2 squared. Okay. So, what do I know? X minus 2 squared is positive. Add the 1, still positive. So this thing down here is positive. I've got minus 1 upstairs, so this is going to be, y is going to be negative. So I think not A and not B, because those are positive. I think y is always negative. Quick sanity check. If I stick in x equals 0, I get y is 1 over minus 5. Okay, that is negative. Great stuff. These graphs aren't labelled, so I don't know which of those is 1 over minus 5. What else do I know? So I think this has got some sort of interesting point. I said when this was a quadratic, I said that was the minimum of the quadratic when x is 2. The minimum of this quadratic is going to be the minimum of 1 plus x minus 2 squared is going to be the maximum of 1 over that, which is going to be the minimum of minus 1 over 1 minus x minus 2 squared. All of those happen at x equals 2. So sort of the minimum of the quadratic is the maximum. I've gone out at the bottom of the screen a bit, sorry. I was giving you the maximum of this 1 over the thing, and then there's a minus sign, so it becomes a minimum. What I'm saying is I think there's a minimum to this function at x equals 2, which is a positive number. 2 is positive, so I think it's going to be C. I think it's going to be this one. Okay, so this is Math 2009, question 1G. It's slightly modified to remove the labels on the axes. Sorry, I thought I'd make the question harder by removing the labels. It's one of those ones where we give you an equation to solve, like how you've seen x squared plus y squared equals 1 for the equation of a circle. I mean, this is not a circle, and we'd like you to find all of the solutions to this equation. Once you've found all the solutions, you could think about where they lie in the xy plane. And there's 4 options here of what that might look like. Okay, so a kind of wrong answer to this question would be the following. Say, well, sine y equals sine x, so y equals x, right? Just cancel the sign on each side, you know? You've got sine y equals sine x, just cancel the sign. Off each side you get y equals x, easy peasy. I want y equals x. This is not the full solution, of course. There are other, I mean, it's none of the options. There's other solutions out there as well. You know this because you know that sine is periodic, that it takes the same values again for different inputs. So there are other inputs for x that I could try, and other inputs for y that would give me the same value out there. So this is not true, this so y equals x thing. But it does include y equals x, because those are some of the solutions, some of the points. This is some of the points, and the points with y equals x definitely have the same value of sine. So our solution should include the line y equals x. Okay, what other line should it include? Well, we've just said sine is periodic, so should also include, here's what I'm going to do, grammar, should also include y equals, if y is 360 degrees more than x, whatever x is, we know that sine x is equal to sine of 360 degrees plus x. So those will have the same value. Okay, is that enough? Well, I suppose also we could have 720 degrees. or other multiples of 360. So we should have y equals x, and then also y equals x plus 360 degrees, 720. Oh, hang on a minute, that looks a bit like a if this is 360 and if this is 720 up here. Okay, I guess these ones are also, you could have x minus 360 degrees. Okay, so it's looking a bit like a, or at least it includes these lines in a. I don't feel happy about d because d doesn't include the point 0, 0. 0, 0 is definitely should be there because sine 0 equals sine 0. Same problem for b. Not happy with b or d. Okay, I've got to decide between a and c, and actually if I look very closely, c has got all of these lines in it as well. It's also got lines going the other way. Let me think a little bit more. I suppose I know that sine, as well as being periodic, it also takes values multiple times. Like there's multiple solutions to sine x is any number between 0 and 1 in this range. So there's also facts like sine of, what's this fact that I want to write down here? You know, I'm pointing to this bit. So our solutions should include all of these as well. So we should include y equals 180 degrees minus x. Okay, and I suppose we should also include, well, I mean, we should also include a lot more things. Also, I can combine these rules together. I should include y is 540 degrees minus x. Those also have the same value. These lines have negative gradient, and they go through 180 and 360, so they go through points here and here, and actually that means they are these lines going this way in this picture, going through things like 180 degrees, 360, that was one of the ones from before, and 540 over here. I think the answer is C. Okay, lots of different ways to have different values of y of x, not just y equals x. So here's another question where we've got an equation to solve. We'd like to think about what the solutions are, and again it's very tempting to say, well, I've got cos squared x equals cos squared y, so I should just cancel the cos squareds and I'll get y equals x. Again, that's not the full solution, but our picture will include the line y equals x. Those will, if y is equal to x, then I mean clearly the sides of this equation are equal. What does that rule out? So that rules out a and d, which are nice pictures, but don't include the line y equals x. Okay, b and c, if I mark on this point 180 degrees, on the picture, which I removed without realising that made the question impossible. The original question had labels on the axes. If this point is 180 degrees, then I suppose I should think about whether that point's on the graph or not. So that's x is 180 degrees, y is 0 degrees. Cos of x squared is going to be minus 1 squared, and cos of y squared is going to be 1 squared. Oh, and those are both equal to 1. So this point is on the curve. Not curve, but is on the graph. Okay, so I think that means that it's not B, is C, this point is on the curve. Oh, hang on, what about E? I forgot about E again. Always forgetting about E. E's different from all the others, isn't it? It's strange, the longer I look at it, the more I get drawn in. So looking at what's... Anyway, how am I going to say whether it's E or not? Well, I suppose I should think about whether this line is part of the answer or not. Maybe I can think about whether this line is part of the answer or not. That might be easier. Yeah, this one's got lots of lines in, a bit like the previous question we did. And just like the previous one where we thought about sine being a periodic function, I suppose I could think about that over here as well. That if y is equal to x plus 360 degrees perhaps, then I suppose cos squared of y is going to be cos of x plus 360 degrees, and then you square it. That's going to be cos of x squared. So that's going to be on the graph as well. weird extra step here, just to say if y is x plus 360 degrees, so a line like this, then that's part of the solutions as well. Okay, so I've kind of eliminated options. Maybe that's not a very satisfying way of making progress. Maybe I should try and find all of the solutions to this equation. So let's try and do that. So this is either, so if cos squared x is equal to cos squared y, then I have it's either the case that cos x equals cos y, or cos x is going to be minus cos y. Those are both possibilities. If cos x is equal to cos y, then what are the solutions to this? So if cos x is equal to cos y, then I might have y equals x, or y equals x plus, and then a multiple of 360 degrees, m times 360 degrees. Or I suppose I might have, thinking about what cos looks like, I might have y is equal to minus x plus 300 m times 360 degrees. I might do 360 degrees minus x. Let's draw a better picture. This is cosine. If x is over here, then I could have y being over here somewhere, 360 degrees minus x, and those would have the same cosine. Okay, I'm also interested in points with cos y equals minus cos y is minus cos x. What are they going to have? They're going to have, so I think I should look at what's going on near. Oh, I can bring something like, for these ones I could bring the minus sign inside. Well, not quite bring it inside, but I could say cos x is equal to cos of y plus 180 degrees, because I know that when you translate cosine by 180 degrees you get a minus sign out, and then do something similar, right? Do something similar to what I did over here to say either, so y is equal to x plus m times 360 degrees plus 180 degrees, or sorry, minus 180 degrees, or y is minus x plus m 360 degrees minus 180 degrees. But I can have similar logic to what was going on over there. So I've got these four groups of lines. This is a huge mess, I'm sorry. Well, these four different sets of lines going through different points, but they're all either parallel to that way or the other way around, and they include this point over here. Okay, so that's my full solution.